Hey guys, it's me, cyoubx. I'm wearing my engineering shirt today so that So yesterday I made a video showing this timer modification I made so that my friends could harass me while I solve, and you guys seem to love it, so I made another video. This time I made a timer out of a cardboard box. But this is not just any cardboard timer, it's very portable. If you have a hoodie, it would be pocketable. And it also uses infrared sensors, much like the YJ Pocket Timer, except this one's better because it actually connects to cstimer and the infrared sensors actually work. So in this video, I'm going to show you how I made this, what the thought process was, and also explain why the YJ Pocket Timer doesn't work as well as people hope. So maybe first I should show you how this thing works. So let me change camera angles. I always knew that having a ThinkPad and being able to fold the screen down like this would come in handy one day. All right, so the way it works is pretty simple. Basically, here in the cardboard cutout, there's a little port. You just connect that via USB. You can see that there's some LEDs that shine. It's very pretty. Now we have cstimer running, the driver is running, and you start and stop it much like you would any other timer. Basically start to the left and right of it. Once you see the green light, then you go, and then when you're done, don't type on the keyboard. There you go. So it automatically enters the time, generates the next scramble. It's all good. Now technically this is supposed to be flipped on this side because the LED is a little bit brighter, so you can see that green light. And you can stop it, but you know, it doesn't really matter what the orientation is, which is kind of cool too. So anyway, that's how it works. So the question that no one asked, how did I make this? It actually wasn't that difficult. Basically inside this box are really simple components. Essentially it's just an Arduino Uno connected with two IR sensors with pretty bad wiring. Originally I was gonna use a breadboard, connect everything, and then even add a nice LCD display. Unfortunately this thing doesn't fit into the breadboard, so I gave up on that. The wiring on the IR sensors is pretty straightforward. There's only 3 pins. There's an anode, cathode, and then an output. The one kind of weird thing I did was this Arduino board only has one 5-volt port. So one of the IR sensors is actually only getting 3.3 volts. The other one's getting 5 volts. It doesn't really matter. The range is so can't say that word. The range is so bad on these things anyway that it really just doesn't matter. The better thing to do would actually be to just drive both IR sensors with a 5-volt source. Unfortunately, I don't have a soldering iron here, and I also don't have any wires. The only thing I had was a breadboard, and this breadboard is not pocketable. So for now, it's okay. One of them has 3.3 volts, the other has 5 volts. It works. I'm not really that mad about it. But I think the really amazing thing I did here was using this cardboard box as my case. I actually designed an entire shell for this thing in SolidWorks, but when I was going to print it, I realized that the thing was really big, and I wasn't even sure if it was going to fit perfectly, so I just decided that I'd use cardboard. So you know all those GAN cubes I have, and how they come with, you know, these atrocious looking accessories? Oh geez. Well, I still don't know how to use those accessories for something, but I did figure out how to use the box that contains them because this was basically the perfect size for this project. It's a little bit thick, but the width and the height were absolutely perfect. So here you can see my laser cutting skills where the cutouts are perfect for the IR sensors, and this is the port for the USB. Before I put everything into the box and then show you some solves to demonstrate that it actually does work, I do actually want to be a little bit serious for a moment and talk about why the YJ Pocket Timer is not that great. So the reason the YJ Pocket Timer doesn't work is because IR sensors in general are pretty cheap. I got a pack of 10 of these IR sensors for $7, and I live in the US, so it's way more expensive than it would be in China. The problem with these IR sensors is that they claim to work between 2 and 30 centimeters, and that's not really false. It's just that 90% of the time it's closer to 2 centimeters than it is 30. So you can imagine if you get 2 sensors that just don't work very well, then you're going to get timers that don't really start or stop very well unless you hit your hands really close to the box. So originally when I bought all these parts, the idea was actually to make a YJ Pocket Timer better, and the way that I was going to do it was effectively just double up the IR sensors. The idea being if you have twice as many sensors sending out signals and also twice as many receivers receiving back those bounced signals, you should be able to get better signal to noise ratio. Effectively, it's like looking at a fuzzy photograph of a person. You might not be able to tell who that person is based on one photograph, but if you have lots of images and you stack them on top of each other, you get a clearer image of who that person is. So to demonstrate the principle, what I've done here is I've just connected the timer to the USB cable so that there's some power. I'm not actually doing any timing right now, but I just want to show you how these IR sensors work. Each of these IR sensors has essentially two modules. One emits the infrared light, the other receives it. So you can see here if I move closer. So you can see on this one, for example, once I move close enough, that second LED lights up. You see that? The idea is if I have two of these next to each other, I have twice as much infrared light going out, and I have twice as many receivers. So I could write some logic in the code to say that if only one of them receives infrared light back, then it's good to go. I haven't done that here, but I just want to show you that the distance actually just increases. So again, this one before tracked maybe like 2 centimeters away. So now when we have two of them emitting light, you can see it's actually more than twice the distance. Okay, maybe it's a little bit less than twice the distance, but you get the idea. More sensors, more good. But only to a certain extent, because obviously as we add in more and more sensors, things become more expensive, they become heavier, they become clunkier. So there's some balance that needs to be struck between performance and portability and cost. So in this case, I'm perfectly okay with my IR sensors. They work between 2 and 3 centimeters, which is good enough for me, but if I was really anal about it and I wanted more range, then I would just double up the sensors. So this is the Arduino code. Basically, this is everything that actually makes this a functional timer, independent of if it's connected to cstimer or not. Basically, the way it works is it's going to always be monitoring what happens to the sensors. If the sensors are triggered, that means one of two things, either that they're trying to start the timer or they're trying to stop the timer. If the sensors aren't engaged, that also means two things. Either the person released the timer too early and therefore just reset the timer so that nothing happens, or they've already held for long enough so you can start the timer. The Python code is also really straightforward. It's effectively just a driver. When the timer stops, it basically sends out the time, and my Python code is essentially listening to that. Once it gets all the numbers, it just simulates the keyboard presses in cstimer, and then once it's done entering all the numbers, it hits enter just like you would on a normal keyboard. The one thing I added here was to make sure that it actually only works in cstimer, so if I try triggering it right now, it's not going to work because this is not cstimer. All right, let me shove the parts back into the box, and then I'll show you the timer in action. You'll also notice that I'm doing this karate chop motion instead of flat hands. It's because I'm using a cardboard box and the IR sensors are too far off the table. I could angle them down, but again, this is jank, semi on purpose. So for now, I'm doing karate chops. So that's how I made my timer. There's a lot of features that I left out that you can implement that would make it a lot more robust. But for those of you new to this stuff and you're interested in programming and making things, this is a nice, easy project. Anyway, hope you guys enjoyed this video, and until next time, toodles.
All the pieces feel the same, don't they?